Okay, we're looking at limits, and we're using the actual definition of the limit, and the idea here is we want to construct a delta. Now in this particular case here, we don't have the freedom of our domain being all real numbers, but we're actually constricted in the interval between 1 and 3. Now remember, to get this limit here, you just take 2, plug it directly in, you get 2 squared, and which happens to be 4. Now let's take a look at the graph. So this is the graph of x squared here, and this is what we're approaching 2 as x approaches 2, right? From the left hand side, from the right hand side, our limit is approaching, or is equal to, I should say, 4. Now I've emphasized the distance here between 9 and 4 to be 5 because we're going to use that fact. Now our delta can't be any greater than 1, right? Because remember, we're in the interval between 1 and 3, and so delta can't be any greater than 1, right? And our epsilon can't be any greater than 5, even though really our epsilon's always a really small number. But I'm choosing 5 here just so we can stay inside of this interval. Okay, so this is the actual setup here, and the largest such epsilon I said was 5, and the largest such delta is going to be 1. Now 1 happens to be what? 1/5 of epsilon, right? So this is 1/5 of epsilon. So our delta could be 1/5 of epsilon, depending on what epsilon is. If epsilon happens to be 5, then delta is 1. But if epsilon is a really small number, right, then we would choose this right here. And of course we would say this. We'd say, well, we want to let delta equal the minimum of this set right here. So remember, if epsilon were 5, then we would just be choosing 1. But if epsilon's really small number, right, we want to choose this right here to be our delta. Now if we weren't on the staying inside that interval between 1 and 3, we would work this just like we'd worked previous problems, where we take the conclusion here and find the solution set. So we have drop the absolute value bars, and it's less than epsilon, drop the absolute value bars, flip the sign, and make epsilon negative. Okay. And then bringing the 4 over, and then square rooting both sides. So x must be less than the square root of 4 plus epsilon, or x must be greater than the square root of 4 minus epsilon. Actually, this should be an and statement right here, not an or. It's an and. And so our delta is actually going to be the square root of 4 plus epsilon minus 2, 2 minus square root of 4 plus epsilon. Right, remember how we get this? We take the difference of these two, and that gives us our delta. This is just like the very first problem we talked about, the discussion on the definition of the limit. And we want to make sure that we take the minimum of these two right here, okay? Because these guys take on different values for some given epsilon. Remember, we're talking about for every epsilon greater than 0. And I did an example here. I let epsilon be 0.1. And after doing the arithmetic here, as you can see, I get 0.0248 for one of the deltas, and I get 0.0252 for the other delta. And so that means that we should choose this delta right here. This is the one that we must choose. Okay, this one right here. Let's look at the graph. So that would be over in this direction here. Alright. So this distance right here, now, right, pretend this doesn't exist, because remember, we're on the real number line now. But that delta is coming off over here, and it's a smaller number. Now I talked about this in the discussion, the reason we want to choose the smaller delta compared to this other delta. But even though it's the largest such delta within that small delta,